This video explores the pollination of 3 Australian tongue orchid species, whose unusual flowers mimic a female wasp and lure male wasps to copulate with them. Tongue orchids are named for the striking red tubular labellum that resembles a rolled tongue in most species. Tongue orchids have a special place as the first Australian orchids to be recognised for cheating their pollinators, following observations by Dorothy Coleman in 1927. Dorothy observed the strange behaviour of colourful ichneumon wasps on the small tongue orchid Cryptostylis leptochila. Instead of entering flowers head first, as they would if feeding on nectar, the wasps backed their abdomens into flowers. Subsequently, Dorothy's mother Edith famously demonstrated the wasps were all males, and that they coupled their genitalia with a ridge at the base of the labellum, a phenomenon called pseudocopulation. Small tongue orchid flowers produce no nectar and rely entirely on pseudocopulation by the orchid dupe wasp, Lysopimpla excelsa, for pollination. The males are so completely deceived that mating is fully consummated, with deposition of sperm in the flowers. Edith Coleman further discovered that the orchid dupe wasp also pollinates the large tongue orchid by pseudocopulation. And we now know that all 5 Australian species of tongue orchids are pollinated exclusively by the orchid dupe wasp. While males are mating with the flower, their abdomen is pressed against a sticky disc, the visidium, which adheres near the tip. Attached to the sticky disc are bundles of bright yellow pollen, the pollinia, that are pulled free of the anther when the wasp withdraws. As in many orchids, the entire pollen load is removed by a single pollinator visit. The positioning of the pollinia on the wasp is the same in all 5 tongue orchid species, which raises the possibility that since all 5 orchids share the same pollinator, pollen is likely to be transferred between species, potentially resulting in hybridization. Yet, even though different tongue orchid species may occur in the same habitats, no hybrids have been found, and all attempts to artificially cross tongue orchids have failed, indicating there are post-pollination barriers to hybridization. The orchid pollinia are cleverly positioned in one of the few places on the wasp where they would not interfere unduly with its day-to-day activities. They are just clear of the wasp's wingtip and genitalia, allowing it to fly and mate normally. Nevertheless, wasps are acutely aware of the encumbrance and may vigorously, but unsuccessfully, attempt to remove it with their hind legs. Sharing of the same sexually deceived pollinator by 5 closely related tongue orchid species indicates that the varied colours and shapes of the distinctively different orchid labella all mimic the same female wasp, which raises an interesting question. Why do males of the same wasp species attempt to couple with such different-looking pseudo-females, especially since the orchid labella all bear only a passing resemblance to real females, which look much like the males? The answer is that the main attractant to the flowers for the males is not the physical appearance of the female decoy. Rather, it is odours or scents emitted by each orchid species that exactly mimic the sex pheromone used by female wasps to attract males from a distance. In this last clip, we see that, no matter how highly evolved a pollination mechanism might be, things do not always go according to the textbook. In this case, a male orchid dupe wasp, already mating with a large tongue orchid flower, is joined by a smaller rival. Neither male is prepared to give way, so they both continue coupling. When they withdraw, the wasps are bound together by the sticky disc, half attached to each. For quite a while, neither wasp seems to know what to do. In the end, the smaller wasp decides to make a determined bid to get free. In the ensuing tug-of-war, the small wasp manages to disengage, leaving the pollinia placed to one side of the large wasp's abdomen. This displacement of the pollinia to the side is not optimal for deposition of pollen onto the stigma of other flowers the large wasp may visit. This episode is likely a rare event. Even so, it illustrates a key feature of the deceptive pollination strategies that are so prevalent in orchids. All such strategies exploit urgent behaviours that drive insects in their few short weeks of adult life, such as the need to find mates, prey, or somewhere suitable to lay eggs. In tying their pollination to the urgent sex drive of a single insect, albeit a common and widespread species, tongue orchids have gambled that specialisation is more efficient for reproduction than generalising on multiple pollinators and competing for their attention with many other nectar-producing plants. Orchids have shown the greatest tendency among flowering plants towards deception of pollinators and pollinator specialisation. At least 10,000 orchid species, or 1/3 of the world's orchids, defraud their pollinators.